All right, we are in Algebra 1, Lesson 2-9. Today's date is Tuesday, October 1st, or first day of October. So it's 10/1/2019. We're talking about multi-step linear inequalities. So linear inequalities is the word of the day. I guess inequality is even more important for the word of the day. Is there a quiet raise hand who can read our objective? It was going to be Emma.
Solve linear inequalities.
There it is. Solve linear inequalities is indeed what we're doing. Thank you, Game Warden, for getting her 50 XP. So let's start with some vocab. What is an inequality? So it's basically an equation. You guys have been dealing with that. 2x equals 8, and you have to do something to it, right? It's an equation, but the equal sign has now been changed. It's been swapped out into something like these words down here. Is there, well, I'm just going to read them off. Sorry, guys. So it's going to be a less than or equal to, a greater than or equal to, or a not equal to. These 5 symbols are inequalities. So again, I'm going to repeat it because I believe it's important. Also, shut your laptops. Forgot to say that. I'm going to repeat this. It's important. It's basically an equation, but instead of an equal sign, you swap that out for one of these 5 signs. Although I don't think Khan Academy really likes this one because it's basically the same thing. So these are the main 4 that you're going to be dealing with. Less than or equal to, greater than, or equal to. There are no questions at this point. No. All right, so quiet raised hand. Actually, we're going to get 5 people to actually stand up and do these. 5 people who wants to stand up and actually write down the symbols for less than or equal to, greater than, equal to. Make a line. Who have cards? This can go. Charles is going to do the first one, then Esha, then Jade, then Larissa, then Eamon. I think that's 5. Go ahead, go for it. As I call you up, just go for it. You can just use the marker if you want. Esha, you're next. Just the sign, yep. Nice and fast. Jade, get up right behind her. Then Larissa, then Eamon. Easy 50 XP per person. Yes, please. That'd be very helpful. It is indeed. Nice job, Larissa. And finally, Eamon. Perfect. All right, so we know what all of our symbols are. Make sure that you have them written down. Make sure you know how to say them. So, I don't know how you guys learn these, but I mean, when I was in, I don't know, like 8th grade or 7th grade, I always learned that when it's, the alligator, it tries to eat the bigger one. So if this one is going this way, this one is bigger, which means this one is less. So this is saying this is less than this one. Alligator's eating the bigger. That means this one is smaller. This says less than. This quantity is less than this quantity. This quantity is less than or equal to this quantity. Well, if it's bigger than, this side is greater than that one. That one is smaller. You always read from left to right. I can't go backwards. I mean, you can read it backwards, but it's going to be very confusing. Read left to right like we do in English. So if I'm reading left to right, this one's going to be smaller than this one. All right. Hopefully we're okay. I know that we're going to make mistakes as we move on, but that's how we learn. All right. So you will make your own examples. Do not copy down my examples. Less than, equal to, greater than, equal to, not equal to. So my example is 1 is less than 2. Make your own example. I'm going to do 2 examples for this one. I'm going to say 1 is less than or equal to 1. That's actually a true statement because it's or equal to. I can also say -5 is less than or equal to 2. That is also a true statement. Make your own. Do not copy mine. Make your own for all of these. Greater than. I can say that 100 is definitely greater than 1. I can say 3,000 is greater than or equal to 2. And I can say 3 is greater than or equal to 3.
Wait,
so that 3.
3,000 isn't equal to 2.
It is greater than 2, though.
Greater than.
Yeah, so you get both choices. It can be greater than or it can be equal to. And I can say that 2 is definitely not equal to 1. Or pi is not equal to e if you assume e is Euler's constant. Cannot write.
But I feel like then you should not use the less than or equal to. You should just use less than.
But what if you can be equal to? Like, do you want to use two different symbols too? So I'm saying less than or equal to is the equivalent of saying, can I actually touch this board? I am greater than this board in terms of the distance from the board, but I can also be equal to the board. I can be touching the board.
But two different numbers can't.
Two different numbers if you're just talking about numbers, but we're going to have to jump into variables, and we don't know where those variables live.
Oh, so like x could be less than or equal to y?
Exactly. Yep.
Oh,
Charles?
For your statement on there, pi is not equal to e,
Yes.
but e could be pi.
You're assuming e is a variable. E, in most mathematical terms, is never a variable. E is always Euler's constant, which is 2.71818, or 1828, something like that. Let's figure out what Euler's constant is. Let's take a side trip. Euler's constant. Euler's constant, that's not right. What is E? E equals, maybe it's not Euler's constant, there it is, 2.71828182846. And it goes on and on forever like pi. It's another pi, but different, and in my opinion, cooler. I don't know why pi gets all the fangirls, I guess. Memorize digits of E, memorize digits of phi, but pi, I mean, it's cool, it has a circle. Alright, so when we're solving, we have to add an extra rule. I'm going to explain why we need the extra rule before I tell you what that rule is. So let's say that we have the statement 7 is greater than 5. Can we all nod our heads? 7 is definitely greater than 5. This is a true statement. I'm going to multiply the left and right by -1. You can do that with me. Multiply the left by -1, multiply the right by -1. And what's going to happen now? Go ahead and write down the resultant. So when we do that, it's going to be the -7 is greater than -5. That is no longer true. -7 isn't greater than -5. -5 is actually greater than -7. Yes.
But it's not like 7 would be greater than 5, but 7 times -1 and 5 times -1 wouldn't be. But since the -1 wasn't already written there, then it should be still the 7 is greater than 5.
You're right. So the original statement is correct, but we're trying to apply the same rules of solving equations where as long as I do the same thing to the left and the right, I should be able to get a true statement. We've shown that when we do that, it's no longer a true statement. So we need to come up with a rule that makes this still work. And that's exactly how math works. You're like, all right, let's try to have all these systems and make sure that they still work. And then it's like, oh no, I broke my rule. Well, let's add another rule so that it still works. That's the general idea.
But
Yes.
how did you know to do -1 on both sides?
I could have done -2. I could have done -3. It was just kind of random. Let's try dividing both sides by -2 on this one. I'm just kind of doing random numbers. Divide both sides by -2. Divide both sides by -2. What happens? What is -6 divided by -2 and 4 divided by -2? Quiet raised hand. Who can do the division? Wyatt?
Okay. -6 divided by -2 would be 3, and 4 divided by -2 would be -2.
All right. Is 3 less than or equal to -2?
No.
No. Okay. So it broke our rule. So what was happening here that broke our rule?
Multiply or divide.
By
By a
Negative
negative.
number.
there it is. Yeah. Let's write it down. We'll give Ulysses the 50 XP. So
I get 50 XP too.
the rule is we need to switch this sign. So if it was a greater than, switch it to a less than. If it was a less than, switch it to a greater than. If it was a greater than or equal to, switch it to a less than or equal to. Just switch the way that the alligator is facing, I guess. That's if you multiply or divide. So if you multiply, can't spell here, multiply or divide by a negative number. The negatives were the thing that broke our rule. If I multiply by a positive, if I subtract, those are all okay. It's strictly when I only multiply, when I only divide by a negative. I can multiply by a positive, that's okay. It's still the same thing. I'm only going to switch when I multiply or divide by a negative. Let's try that out. I have 2 examples for you guys, and then we're done. Example 1 on the front, 2 on the back. I'm going to do example 1 with you guys. Example 2, you guys are going to solve on your own. Here we go with example number 1. Pretend that this is an equal sign, just like we were doing before, and solve this with the extra rule right here. So, what is the first step? And there's a bunch of good possible first steps. Emma? We'll go with here next.
Negative 4x for both sides. Yeah, or you subtract 4x by both sides.
Let's do it. Minus 4x on both sides. Everyone write it down. That will cancel out the 4x. And Emma, can you read our new line after we subtract 4x on both sides? So they're both negative, so you're going to add them and then take the sign larger. Perfect. Thank you. All right, that's a good first step. Next step. Go for it, Kira.
Subtract 10 from 10 and 23.
Let's do it. Subtract 10 from both sides. And Kira, can you tell us what our new inequality says?
13 is greater than negative 6x.
All right, and our final step, remembering that extra rule now. Be careful here. If you did it the other way, then you're not going to have to switch the sign. So yeah, that'll still work. Larissa, you want to give it a shot?
Sure. You can multiply by 3.
Multiply by 3.
Negative 3.
Multiply by negative 3 on both sides like this. How is
Or
it?
would you just do it the same and divide?
Yeah, divide both sides by
6.
Negative.
Negative.
There it is. Divide both sides by negative 6. Oh, look at that. Whenever I divide by a negative, that's the rule. Whenever I divide by a negative, I need to switch the sign. So Larissa, go for it.
It's just like what we've regularly been doing.
Exactly.
Like, so what we just did, the extra rule thing, we don't do that.
We are going to do that extra rule because we are now dividing by a negative.
Oh, okay. So then it would be.
This is
The
going to.
answer would be a negative, right?
Yep, negative.
Negative.
Just leave it as a fraction, an improper fraction.
13 over 6. Oh,
And then what's the sign?
X. Oh, no.
What's the sign that
It's
goes
greater
like that? Not quite. So it was a greater than, but because I
than.
multiplied by a negative,
Or equal.
no, I should flip the other way. So instead of chomping on the left, it chomps on the right. How do I pronounce the one that goes like this?
Less than.
There it is, less than. This sign switched to this sign, and now it's a true statement.
But why do you do that?
It's because of this rule up here. We had a true statement, but whenever we multiply by a negative 1 or divide by a negative, whenever you multiply or divide by a negative, you need to switch the sign. Otherwise, you'll have a false statement.
So I did it the other way, and I did not have to switch it by using a multiplier divided negative.
Yeah, I'm going to write out Charles' way. I know exactly what you did, Charles, so I'm going to go ahead and do it. So this is what Charles did, which is kind of cool. So you guys do not need to write this down as long as you sit back and relax and pay attention. So he had 4x plus 23 is greater than negative 2x plus 10. From there, he added 2x to both sides, plus 2x plus 2x. That cancels out the 2x, and I'm left with 6x plus 23 is greater than 10. From there, he subtracted 23 minus 23 minus 23 on both sides. Negative 13, thank you, Charles, is going to be, so I have 6x on this side. 6x is still greater than negative 13, and then from here we divide both sides by 6. Let's do that in black. Divide by 6, divide by 6, and I get x is greater than negative 13 over 6. It's the same answer, but notice that the x is on the right side versus the left side, and whenever I switch the side, I'm also switching the sign back and forth. If I read it backwards, I know that we read from left to right in English, but if I read it backwards, it's saying x is greater than negative 13.6. If I read it forwards, negative 13.6 is less than x. If I read this one forwards, it's x is greater than negative 13.6, which is exactly how you read this backwards. X is greater than negative 13.6.
So they're saying
These are both the same answers. Yes.
It's just the way you solved it that they turned out.
In fact, I would say that Charles's method is slightly easier because you don't have to do this extra rule. We never had to switch the sign. Greater than, greater than, greater than, greater than. We never had to switch because we never had to multiply or divide by a negative. But if you do have to multiply or divide by a negative, then you are going to have to put the sign, put a greater than to a less than.
Recrafted by rule.
Are you guys ready to go for example number 2? Ask questions. Otherwise, start on example number 2. After you check example number 2's answer with someone else, then you may begin on Khan Academy.
Yeah. I'll tell you again.
No, you
All right, Eamon, it's yours.
See, even Lozzie disagrees with me.
If you guys don't know what you're doing, you're paying attention to Eamon. He's going to be explaining how to do this one. If you know what you're doing, you may move on to Khan Academy.
So,
Once the lesson finishes, I should decide if you guys are positive or negative. So we can divide both sides by 12, sorry.